Alright, let's revise the simultaneous equations, which is using the elimination method. Okay, elimination method is actually quite useful. Like for instance, if you have this case here, which is like a real life example, right? You buy 2 burgers, 3 drinks, you pay $18. Or if you have bought 2 burgers and only 2 drinks, it will cost you $16. So actually, simultaneous equation is all around us. So from here, you can kind of guess, okay, how much is a drink and how much is a burger, right? So you are actually using simultaneous equations without realizing it. So let's just put this into an algebraic form. So like for instance, the first one earlier on, you'll notice that this is actually going to be your burger and this was actually your drink, correct? So what we're going to do is that we'll try to use simultaneous such that we will have one positive and one negative, okay, like this case here. So what we're going to do is that we have 2x and negative 2x. So what I basically have done is that I'm going to change all this to negative, okay, 2x, 2y, and 16. I'm going to multiply negative throughout all. So it becomes negative 2, negative 2y, and negative 16. Now, why I do that is that instead of taking the difference, right, because sometimes it's hard to remember for elimination method, do you add or do you subtract? So to make it easy, what we're going to do is that we're just going to use addition all the time. But in order to do that, right, we are going to have one positive and one negative term. Why? It's because based on the concept of zero pair, it will be zero when you add them up. All right. So what we'll do is that equation 1 and equation 2, when we add it up, this becomes 0. This one here will become just y, because 3y add to negative 2y is just y. 18 add to negative 16 is just 2. So there you have it, y is 2. In the previous example, that was actually the price of a drink, so it's $2. Now, once you have the y, you can actually find the x, which was the price of the burger, right? So I can actually use either equation 1 or equation 2, it doesn't matter. So I'm just going to pick equation 2. Now 2x plus 2y is 16. So this means that when my drink is $2, right? So I have here, this is 4. So doing balancing, minus 4 on both sides. Okay, so this one here, I can actually do a balancing, minus 4 and minus 4. So 16 minus 4 will give me 12. So x equals to 6. So in other words, one burger is actually $6. Alright, so let's go through some of the steps that we can use for simultaneous equations by elimination. You can choose to eliminate either x or y. It doesn't have to be x all the time, but if you want to, you can. So I've put here that we want it to be the same value. When I say same value means that if you have 2x, then you have another 2x, but one positive, one negative. So 2x and minus 2x, or 5x and minus 5x. Okay, something like that. Why? Is because of the concept of zero pair. Alright, when we have one positive, one negative, they can add up into 0. So for this method, right, no matter what you do, you're always going to take the sum of the equation. Alright, and you will always solve for 1 first. So if you've already gotten rid of x, so basically you'll be solving for y. Then after that, use that to find x. Alright, so let's try a couple more examples. Okay, so this first example, as you can see down here, right, you have 2x minus 3y equals to 11. Equation 2, x minus y equals to 7. So let's try to make this one into negative 2x, because if this is 2x, I want to make this one into negative 2x so that they are the same value, so to speak, but one is positive, one is negative. So how do I change this one into negative 2x? It's by multiplying this term by negative 2. But what you do for one, you have to do for all. So that's why I put down here, equation 2, I will multiply with negative 2. Alright, so x times negative 2, you get negative 2x, minus y times negative 2, you get positive 2y, and 7 times negative 2, you get negative 14. Alright, so what I have done now is that I have a zero pair, 2x and minus 2x. Alright, so we have it here. So this is your zero pair. So once you have one of them positive, one of them negative, again, we are going to use an addition. Alright, we're going to add them up. So what you have here is that when you add this up, you will be able to get a zero pair, right? This one adds up into a zero pair. So negative 3y plus 2y will give you negative y. And then 11 plus negative 14 will give you negative 3. So if negative y is negative 3, then y is 3. Correct? Now, once you have that, right, we can put it back into the original equation. Now, let me just write it at the side here. X minus y was equals to 7, right? But now that we know that our y value is actually 3, correct? So x minus 3 must give me 7. So let's do balancing. So I plus 3 on both sides. So that's how I get x equals to 10. So once you have the y value and the x value, that is your simultaneous equation. Right? So let's try a couple more examples. So for this example, you can see that, again, we do not have anything that's roughly the same yet. Okay, so what we can do is that we try to make the x term the same. So the same meaning that let's make it into 12x and 12x, but one negative, one positive. All right. So what I'm going to do is that for the first equation, I'm just going to multiply by 3 because negative 4, when I times 3, I get negative 12x. All right. Then, okay, so this one here times 3, I get this. 5y, I times 3, I get 15y. 14 times 3, I get 42. For this one here, in order to get 12, I just have to multiply by 4, which is here. So I have 3x times 4 will get me 12x. 2y times 4 will give me 8y. 1 times 4 will be 4. Right? So again, here you notice that I have one pair of 0 pair. Negative 12x and 12x. So again, I can use addition. Alright? So I will add them up. So in this case here, the 0 pair is gone. So I just have 15y plus 8y will give me 23y. 42 plus 4 will give me 46. So dividing both sides by 23, I'll get 2. Now I'm going to use equation 2, which is from here. So let me just write out again. 3x plus 2y equals to 1. But now you know that your y value is supposed to be 2, correct? So that's why I replace y as 2. So this one here is 4, correct? So I do a balancing, minus 4, minus 4. So 3x equals to 1 minus 4, which will give me negative 3. So dividing both sides by 3, I get x equals to negative 1. So I have y and x value. Now, what if I have a case where I have fractions, all right? So the first thing to do is that we can actually multiply everything by 2, right? Because the denominator is here is 2. So I can times 2, times 2, times 2. So the 2 can divide out. So what you do for one, you do for all. And I will end up with 2 times x is 2x. So this one here is just y. And this one here, instead of 9 over 2, it's just going to be 9. Now, 4 and 6, the LCM is not 24, it's actually 12. So I'm actually going to do times 12 to everybody. Okay, times 12. So you notice that 4 and 12, I will get 3. 6 and 12 here, I can divide out. And this is what I have. Okay, so from here, I will have 3x. And this one here will give me minus 2y. And 5 times 2 will give me 10. So I have equation 3 and equation 4 without any denominators. Now, this is where we go back to whatever we have been doing previously. Alright, so let's try to get rid of x. Since we have been doing that, let's do it for the same. Okay, so I'm going to make this into 6x. So I'm going to times 3 to everybody. So 2x times 3 gives me 6x. Y times 3 will give me 3y. 9 times 3 will give me 27. For this one here, I'm going to try to make it into negative 6x. Alright, so I'm going to multiply by negative 2 instead. Alright, so 3x times negative 2 will give me negative 6x. Negative 2y times negative 2 will give me positive 4y. And then 10 times negative 2 will give me negative 20. So again, I will add them up. Alright, because I have a 0 pair here. Alright, so I can add them up. So this is what I'm going to have. 3y plus 4y. Then this is 27 plus negative 20. So 7y equals to 7. So y is equals to 1. And then, again, we can put it into equation 3, which is this one here. So equation 3 was 2x plus y equals to 9, right? So now that I know that my y value is actually 1, So I can replace it. So I can do balancing, minus 1 on both sides. I'll get 2x equals to 8, then x is equals to 4. Alright, so these are all examples of how you can use the concept of addition to get rid of one term. Alright, so there is actually a calculator mode that you can use, right, to actually check your answers. So how do we go about it? Okay, so your calculator may look slightly different from mine. Okay, so mine here, right, you will notice that mine is mode 5. Yours should be mode 3 for some of yours. All right. So you look for equation. All right. So I'm going to press 5, equation. Now you may recognize number 3 here for your quadratic. All right. When you're using general formula, this is the one. So we're going to choose number 1. Okay. So look for the number 1 here. All right. So number 1. Then you will notice there are 6 blanks here. So the 6 blanks, right, is actually for x, for y, and for the number. So coefficient of x, coefficient of y, and the number over the other side. Okay, so you have equation 1, equation 2. So let's put in here first. 2, negative 3, and 11. So 2, enter, negative 3, enter, and 11, enter. For this one here, right, where there's no number in front, it's actually just a 1. Alright, so this one will be 1, negative 1, and 7. Right, so we have 1, negative 1, and 7. Press one more time and you see, x equals to 10. That was the answer that we got earlier on. Alright, and you press the equal sign once more and you will notice that you can get the answer for y as 3. Alright, okay, so let's check one more. Alright, so we have already done this one. Okay, so let's check once more. So let's clear the screen first. So in this case here, negative 4, 5, and 14. Okay, so negative 4, 5, and 14. For this one here, it will be 3, 2, and 1. 3, 2, and 1. Okay, equal. So x is negative 1 and y equals to 2. So this calculator method is actually good for checking. Alright, so don't just use it as the main method. Try to use the elimination method, but you can always use this to check your answer. Alright.